Hey there, and welcome to another Sneak Live. I'm your host for today's session, Brian Clark. I go by Clarkio on the internet, and I'm a developer advocate here at Sneak, and I'm excited to have you here for this session. Good afternoon, good morning, good evening, wherever you are in the world. Thank you for joining in. Now, question for you. If you are a developer, do you think about security when you're building out your applications? It's okay if not. I'm not going to judge you for that, but you should be. And in case you're wondering why you should be, well, today's session has you covered because it's going to talk about and demonstrate some of the things you should be considering, thinking about, you know, when you're building out your applications. What should you be, taking into account for when you're doing this stuff and how to even know about it on your own. And so to help us learn more about that, and without further ado, let's introduce our speaker for today, who's going to be talking about stranger danger, how your JavaScript attack surface just got bigger. And that is Sonia and Patch.
Hey, hi everyone. Thanks, Brian. So welcome to today's session. Stranger Danger, your JavaScript attack surface just got bigger. Let's start. So what are we going to have a look at today? So we're going to talk about the current state of open source software and what are the hot topics around that. We're also going to talk about the iceberg, and you might be like this little emoji saying, what is she talking about? But I'll get there. We're going to have also a live hacking session with the help of Patch. So we're going to also remediate and fix those vulnerabilities. And obviously, we're going to have some learnings along the way and see some defense in depth advice. So let's start with the current state of OSS. So we know that organization of all sizes are reliant on software, and much of that software are actually composed of several open source software components. Thus, open source OSS has cybersecurity implication, which is an attractive entry point for attackers, people and organizations interested in theft, in disruption, or exploiting economic and political gain. So we've seen that the attack surface has been changing, and this is different from one we've been knowing in traditional cybersecurity threat models. And defects in small libraries can cause systemic risks, and we've seen it last year with the incidents like Log4Shell. So we can ask why application security is important. And we know that vulnerabilities can originate from something as simple as a configuration error or using a software component that contains a known vulnerability, which is why maintaining and improving your application security is so important for businesses. So one recent study revealed that out of 85,000 applications that were analyzed, 83% contain at least one security flaw. And of these, 20% has severe vulnerability. While we know that not all of these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate softwares. And we have organizations such as OWASP, which stands for Open Web Application Security Project, that tracks vulnerabilities found and provide a list that developers and security teams can use as a starting point for their application security program. And the most recent OWASP Top 10 list was released last year in 2021 and included broken access control, injection attacks, security misconfigurations, and more. So let's have a look at some of the open source software attacks. The first one is typo squatting attacks. So typo squatting attacks takes place when bad actors push malicious packages to your registry with the hope of tricking users into installing them. So this is quite similar to what we have with website phishing attacks that exploit typos made by individuals who may accidentally typing a wrong address. So here we have an example with the package React with a typo. And in that case, you will not install React, but a malicious package that has a completely different end goal. Another example is malicious packages which inject malicious code into a software product in order to compromise dependent systems further down this chain. So in this example, we're having a package called Fall Guys, and usually the malicious actor will try to serve on trends. So in that case, the game has been quite popular during the pandemic, and user might think that by downloading this package, you'll have an advantage in the game. So you can do this within the game, like, I don't know, improving like your cosmetics or having more ammunitions or those kind of things. But in that case, Fall Guys is a malicious package that contains malicious code that attempts to read local sensitive files and exfiltrate information through a Discord webhook. So this was the entry point in that case. And the code attempted to access specific paths available on Windows systems. So in that case, it was checking the local storage level DB. One last example is compromising maintainers, where malicious actors will be using social engineering methods to gain access to open source projects. So here we have an instance with the event stream package where the malicious actor did social engineering the maintainer. So what it is quite interesting, he went through all of the issues from that specific repo, and he was looking if he could contribute and push some codes and just improve in general. What was it? Just to build up the trust. So at first he pushed some cosmetic changes just to, as I say, build up the trust with the maintainers. So he pushes changes through like CSS files or README files just to push a little bit of code. And once he got more permissions, he actually pushed his malicious payload into the code base. And in that case, it was targeting a Bitcoin wallet. So his modus operandi was quite interesting in going through all of the issues, see if he can contribute, be trusted by the maintainers and the contributors, and then push his malicious code. So this is known as a supply chain attack, also called third-party attack, and it usually occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. So the bad news is it doesn't affect only JavaScript packages. This is an issue for all ecosystems. And we had a recent example with Log4Shell last year within the Java community with a vulnerability in the open source Apache logging library, where one of the Log4j exploits allowed remote code execution on the servers running vulnerable applications without requiring authentications. And that has earned the vulnerability a severity rating of 10 on the CVSS scale, which stands for the Common Vulnerabilities Scoring System. And we know that Log4j was used in and is still used in many commercial applications, and organizations might be vulnerable without knowing that they are actually using this logging library. So supply chain attacks are quite attractive to hackers because when it's commonly used software or packages that are compromised, the attackers could potentially gain access to all of the enterprise that use that software. So let's try to understand how this is possible, and let's all say hi to the iceberg. If you're confused by that statement, that's normal. Let me explain to you. So this is the iceberg. And let's start on the tip of the iceberg, the application code. So this is our starting point, our code. This is our proprietary code that we write in an organization. Does it bring security vulnerabilities into our code base? Maybe, maybe not. In that example, we're saying that this is an example of an injection, and because we're not sanitizing the user input. So how is this possible? So here we have a function signature of an express application with a function that has a request, a response, and an X callback. So it's calling the user table on the backend or collection, which means that there's a database behind the scene. And it's trying to do login. So it's looking for the username and password. So what could be the vulnerabilities here? What can go wrong? So as I said, this is a database injection. And in that specific case, this is a NoSQL injection. Applications built with Express will be using body parser to parse the JSON objects, and it takes whatever you send to and convert it to a JavaScript object. So if the request has a username and a password, this is going to be part of the JavaScript object. And if you're using MongoDB and add the greater than, $greater than as a key and an empty string as a value, the JavaScript object will tell MongoDB to do greater than, match, and filter all the results. So in that specific case, you will send a request as an admin, as the username, and this object will perform NoSQL injection and it'll be logged in as an admin. Cool. So this shows the importance of sanitizing inputs and to handle this as soon as possible before it's stored into your database. So we start with our codes and where we can potentially have security vulnerabilities. This is another example with a piece of code to import dependencies, which is a nice segue to the layer below the application code on the iceberg, which is the open source code layer. So if we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we don't want to reinvent the wheel, and this is totally understandable. Why would we want to waste some time to rewrite something that might probably exist as a package in our ecosystem? And that's what we have here with the marked package. So the marked package is used to implement Markdown within our code base. But now we're bringing several packages into our code base, and you could see it with the little red npm packages all over our code, which is basically increasing the attack surface and introducing new risks within our project. And there's a few questions that we need to keep in mind. So are we aware of all the packages that we use? Are we aware of all the dependencies and sub-dependencies that we have? Do we have a good understanding of indirect and transitive dependencies? Do we have tools that help us having that level of understanding and visibility? Also, what are the risks when we bring a dependency into our code base? I know that's a lot of questions, but let's try and see some numbers around that. So we know that the average number of outstanding critical vulnerabilities in an application is around 5, and this will obviously depend on the programming language that we're using. The average top-level dependencies per project is around 80. Also, this will depend and will based on the programming language that we're using. But the most concerning one is the last one. The average number of days it takes to fix a vulnerability is almost around 100 days. So enough chatting for now, and let's move on to hacking an application to understand more about how dependencies can impact your application and introduce vulnerabilities that you're not aware of. So I'll be using a few applications from the Snyk Labs GitHub organizations. The first one will be the Node.js goof, and this is how it looks like. Patch to-do list. Cool. So as you can see, I'll just walk patch. Cool. Bye, Brad. Yeah, as you can see, this is like a classic to-do list. So let's think about how we could potentially tamper with this application. There's a few entry points that we could use. The first one, let's have a look at the URL here. So obviously, I'm hosting this application on my machine, so this is why you're seeing the local host. But imagine that we're serving it on the server. So let's have a look here. Let's think how we could tamper with this one. Let me try if I can access the public folder. Oh, interesting. Okay, I can. Cool. Let me see if I can find anything interesting. So I have a few CSS files, JavaScript files. Let's have a look at the robots.txt. Okay. So this is giving me a little bit of info as an attacker potentially to understand a little bit more about the application. So let's see if we can traverse the directories to try to find more sensitive information, something a little more juicy like credentials or passwords. So let me do the // and oh, I'm back to the homepage. That's a bit disappointing. Let me have a think how I could actually bypass this sensitization, because I know the // should be working. Let me try with URL encoding. So for those of you who don't know what URL encoding is, it's basically, I'm going to try replacing unsafe ASCII characters with a percent followed by 2 hexadecimal digits. And what I'm going to encode is the // So I'm basically going to replace the dot with the %2e and the slash with the %2f. So let's try this. I'm going to go back to the public folder and put this. Interesting. Okay, so this is working. Let me see what I can see on there. We can find out deploy Heroku Markdown. That's giving me a more information. Interesting one. Okay, it's talking about like credit card numbers. Let me see if I can find something else. Ooh, passwords. That's an interesting find. Okay, so you can think as an attacker, this is actually a good way to have access to sensitive data, password, credentials. But let's see if I can continue using this vulnerability and continue traversing the different filters. Okay, interesting. Can still doing this. So obviously, because I'm on my machine, you can imagine like the kind of filters that you can find on the machine. But imagine on the server, and so I keep doing the / sequence and variation on it, and I have access to etc folder. Obviously, I'm not going to click because I don't want to reveal sensitive information. But you get the gist of it. It's an interesting one for an attacker. So what is going on actually here? Let's have a look at the code. So here, as you can see, this is a full-fledged Node.js application using Express and a lot of packages. But in that case, let's have a look at the st package, because this is the package that we're using to serve the static files in this application. And let's see where we are instantiating it. So here, okay, cool. So apparently there's a little bit of issue with this package. So let's have a look and let's ask the help of patch. So before having this little patch icon, what you could do is, I'm using the Visual Studio Code in here. So on the marketplace, you can type Snyk and you can click on this one, the Snyk security code open source dependencies, install it. So the first time you only need to reload your ID to take into account, and then you'll see patch icon here. Click on it. And the first time also you won't see those this in the sidebar. You'll have to actually authenticate with your Snyk account, and then you can run your first scan. This will be triggered automatically. So here you can see there's a lot of vulnerabilities on different packages. Cool. But what we're interested in is the ST package. So let's have a look at the package JSON, and let's hover on the ST package. We can see that there are two vulnerabilities here, and if we hover over this package and click on the yellow light bulb, show the most severe vulnerability. Let's click on this one. Let's close this, zoom a little bit more. Cool. So we do have a directory traversal vulnerability, which is the one that we've been performing, which so yeah, all cool. Here, and we have more information about some metadata around this vulnerability. There's also a link to learn more about this vulnerability. So if you click on this one, you'll be redirected to the online platform, the Snyk platform. And here you can actually learn more about the different vulnerabilities, and you can filter by ecosystem. So if I'm doing JavaScript here and directory traversal, you'll have one lesson on directory traversal just to learn a bit more. And everything is sandboxed, so we can actually try have a go with the different vulnerabilities. It also keeps progress, which is cool. You can learn more about different security vulnerabilities here. So going back to this directory traversal vulnerability, we can see that it has been introduced through this version. So that's the one that we're currently using within this code base. And the good news is it's actually fixed in this specific version. And there's a proof of concept. So let's have a look. So it's saying that the versions prior to this version didn't properly prevent path traversal, and we've seen it. So the literal dots in the path were resolved out, but the real encoded dots were not. So requests like the one that I've been doing on the application would leak sensitive files and data from the server. Cool. So this is known as a directory traversal attack, also known as path traversal. And it aims to access files and directories that are stored outside the intended folder. And this has been done by manipulating the // sequence and variations. Because when I was using this // it wasn't passing through and giving me access to the different files and directories. So I had to URL encode those. And it's saying that also the ST package is a module for serving static files on web pages, because we didn't want to reinvent the wheel and implement this feature. So we've actually implemented this package. And obviously this is part of the information disclosure vulnerability. Cool. So now that we have a little bit more context around that, we want to fix it, obviously, because we don't want this in our code base. So let's fix this. So going back to the package JSON, I'm going to change the version of the package. And I'm going to stop the server. I'm going to do an npm install to reinstall this package. So as you can see, we've been building a 2D app, and we've been implementing this specific package because we didn't want to reinvent the wheel. But unfortunately, it actually did bring a few vulnerabilities in it. So let me just refresh this page, and this has been fixed. I cannot get to this specific path, which is good news because I didn't want to reveal my Etsy folder. So this is great. And just to be sure, let's have a look at the patch icon. So if I scroll down, we can see that there's two vulnerabilities here, including the directory traversal. But if I trigger another scan, this one should be gone because we've just fixed it. So it usually takes a few seconds to run the scan. It's quite quick. And if I scroll down again, one of the directory traversal is gone because this has been fixed. So yay, cool. First one. So let's go back to the home page. And let's have a look at this input here. So Honestly, we can think as an attacker here, we're seeing an input, so we're going to try to actually perform cross-site scripting because this is quite tempting. So let's try it. So as I said, this is like to-do list. So this is usually the usual one that we would try with the script one. Just some having a variation here. And oh, this is disappointing. This one is not working. Okay. Oh well. Let me try with. I'm just testing here if this application is actually using Markdown. Oh, interesting. So what I've been doing here is using Markdown. So if you know what Markdown is, this is a programming language that helps you prettify your text. So you can use different things like paragraphs, lists, links as well, which is an interesting one. And apparently this application is using Markdown. Okay, so let's see if we can use links. It should, because I've demonstrated here that we could use Markdown. So if I right click here, I'm redirected to the Snyk website. Okay, so let's try actually using this link just to perform like an alert. So as an attacker, usually when something is working, I'm just like building up on this payload to craft a better payload. So just trying different things. Here, I forgot this. Cool. So let's see if this one is working. So it's basically using the link format as Markdown. I'm using the JavaScript protocol here to trigger this alert. Let's see if this is working. Oh, okay. Interesting. Of empty closing parentheses at the end. Okay, let's try to build up on this on this payload. Let's try to do some variations because there's probably some sort of sensitization in the backend. It's interesting. So here what I'm doing is I'm actually using HTML entities. So HTML entities is basically replacing the in that case I'm going to replace the colon with, if I can find it, this here. And I'm going to replace the closing parenthesis with this here. So it's basically the same as the JavaScript colon and the alert with one and the closing parenthesis. Let's see if this works. Oh, okay. The response is a little bit different. There's actually no response. This is an empty field, but okay, this is some sort of like message for the attacker. So let's try and improve the payload. So I'm going to continue and just build it like a different kind of payload. So here I'm still using the different variations with the JavaScript colon, but this time I'm using the this keyword with the colon and then the alert with patch and the closing parenthesis. So here we're trying to break out of the logic implemented in the backend that is blocking us from hacking the application. And then we're assuming that the condition must expect exactly the JavaScript colon protocol, but in this case, we're encoding it and adding the this keyword. And this is a valid keyword in JavaScript. And you can also replace the this keyword by window or documents, and it will also work. So we have the HTML entities and the browser permissiveness that will enable this vulnerability. So let's have a look here. And if we click, hey, this is working. We do have an alert. Okay. So if I do another one, so this application doesn't have cookies on the backend, but instead of doing the document.cookies, I'll just do the document.location here, but it's giving me the location here. Cool. So as an attacker, this gives me a word to perform an attack and break out the logic that is preventing the JavaScript to be executed from the backend. And usually for an attacker, that's the first step when testing an application to see if there is any entry point to craft a better payload. And here we have a perfect example of story XSS because the payload is saved in the database. So basically, if I refresh the page, you'll see that this is still here. You can click and this is still showing. So you might say, Sonia, this is cool, but this is just like an alert. And yeah, you're right. But if we think of it like a social media application where you could have user profiles. So visitors could click on the link on the profile and the data would be sent to the attacker's server containing sensitive information. In that case, this could be session cookies, for example. So let's have a look at the code, going back to the code, and let's understand what is going on. So as I said, we're using the marked package here to implement the Markdown within our code base, and we are instantiating it here. So as you can see, we've done a little bit of due diligence. We set the options sanitization to true, but unfortunately, this wasn't enough because we managed to bypass this sanitization. So let's ask Patch to help us and understand what is going on here. So let's have a look at the marked package. I'm just hovering it and click on this light bulb, and we have a cursor scripting attack. Yeah, this is what we've actually showed. Cool. So again, there's a few information on the ratings, and also you can click on the on here and be redirected to the Stickler platform. And here, if I do XSS, you'll have there's a lesson on cursor scripting. Again, if you want to learn more about it. So this XSS vulnerabilities has been introduced through this version, and the good news is it's been fixed on the specific version. Cool. So this is giving you a little bit more info on the marked package, and also the affected version of this package to cursor scripting. So an attacker could bypass its output sanitization with the one that we've actually implemented within the code base protection. And using the HTML coded character set, the attackers could inject JavaScript calling code snippets into the output. So the one that we've actually tried, this will result in an alert being executed when the user clicks on the link. That's giving you a little bit more info on what is cursor scripting attack, when the attacker tricks a legitimate web-based app or site to accept a request as originating from a trusted source. And this is why the social media example is a good one, because user could potentially click on a link thinking this is a legitimate link, and then everything goes wrong, and your data is actually being sent to the attacker's server. So in this case, we're having a stored XSS, as I mentioned. So cool, now that we have a little bit more information about what is going on with the specific version, than this marked package, let's fix it, because we don't want this in our code base. So going back to the package JSON, I'm going to change the version of the package here. I'm going to stop the server and do another npm install. So here you can see that we've implemented 2 different packages with 2 different features. And fortunately, we've actually introduced a few vulnerabilities along the way. But the good news is we can fix them. Let me just rerun the server. And going back to the application, if I refresh it, everything is gone. So this is actually a good sign. Just going to remove all of this and try one last time to see if it's actually fixed. Yeah, we have nothing. Cool. Yay, patch did actually help us fixing 2 vulnerabilities with this this applications. We now have a secure patch to-do list. Cool. So let's go back and see what did we learn with this example. So first of all, we can use the Sneak Advisor to check if a package is secure before implementing it into our code base. So let's have a look. So this is Sneak Advisor. You can see if you click on the drop-down, you have different ecosystems. You have the npm, PyPy, Go, Docker. So let's have a look with the FT package. This was the first one that we had a look at. So here we can see and have a look at the health package, and we have different dimensions. So security, popularity, maintenance, and community. And this is great because it's giving you a few information to better understand what is going on with this this package. It's giving you the version, which is free from security vulnerabilities, giving you the popularity, also graph, the maintenance, when was the last release, the last commits, a little bit more info around the community, maintaining this package, and other data. Let's have a look at the other package marked. And click, and this one is actually amazing. There's like a perfect score, which is great. Obviously, for the purpose of the demo, we've actually used a really vulnerable version. But yeah, the latest version is free for any security vulnerability, so you're good to go, and you can use implement Markdown within your projects. This is giving you a little bit more info on the popularity. It's quite popular package. The maintenance, when was the last release, the last commits, and other metadata. So this is a good way to understand a little bit more what is going on with the package, and if you want to actually implement this package within your code base.
Hey, Sonia, quick question for you from the chat, Plaintext Nerds, which shout out to Plaintext Nerds. Thank you for the raid earlier. They asked, is there a JavaScript alternative to Bleach, which is a Python package for input sanitization that you know of?
Ooh, good question. Not that I have on top of mind. No,
I'm aware of
sure
one, but I don't
necessary.
remember the name of it in particular, but I thought maybe you might know as well.
Yeah, no, sorry, not on top of my mind.
All right.
But
No worries.
oh, me. No, that's fine. Cool. So yeah, there's also different ways to check for vulnerabilities within your code base. I've been using the IDE implementation, but integration. But you can also use the CLI to check the vulnerabilities within your project by using the sneak tests command. So let's have a look at this. I do sneak tests here. This will query the database and mirror what you have here. If I click on the patch icon here, this is exactly what you have. But if you think this is a little bit too much, you can actually filter this. So by doing sneak tests and the severity threshold, I can type it and let's set it to high, so you'd have only the highs and criticals. So again, it will query the vulnerability database, but you would only see the highs and criticals. So if you want to start and tackle those vulnerabilities before the other levels of severity. So this is also a way that you could use, depending on your workflow, if you're more familiar working with the CLI or through the IDE. You can also use the Snyk dashboards, and this you can have more visibility on the Snyk dashboard if you import your project, and you can monitor your project automatically. So if there's any new vulnerabilities introduced in your application, you'll be notified. And this is how it looks like. So here I've actually imported the Node.js goof from the patch to-do list. And if I click here, so it'll give you a little bit more info on the, again, this will mirror what you have on the CLI and the Snyk integration within your IDE. This will, depending on your workflow, you have that kind of visibility. And from this dashboard, you can actually click on this green button to fix this vulnerability. And you can raise a pull request with the selected fix that you want to apply. So you can either cherry pick the repo, the vulnerability that you want to fix, or just bulk fix everything if you feel adventurous. And this will raise a pull request on your GitHub repo. And you'll have more information, also like merging advice if there's any breaking changes. Again, this will depend on your production workflow. If you want to break everything, probably need to run your suite of tests before. And you can also spend some time reading more about the vulnerabilities and do some hands-on labs to understand more about cursor scripting or directory path or other vulnerabilities through Snyk. So let's go back to our iceberg. We haven't forgotten about our iceberg, and let's have a look at the third level. So this is the container level. So an application needs to be deployed somewhere. So we could use containers or a static website to deploy our projects. And we have different ways to do so. So we could use Docker, Vercel, Netlify, or any of the cloud providers. If we're using Docker, we're adding a Dockerfile now in the equation, which has metadata about your project. And there's an additional layer with modern application. So we're running our application as Docker images. This adds to complexity and increase our attack surface again. So good news is Snyk can give you that visibility and help you scanning your Dockerfile. And before going back to potential a live demo, let's go back to really basic Dockerfile. I know, but let's see what could go wrong with this one. So a lot of things actually, if we have a look. So first of all, the common software vulnerabilities, they have vulnerabilities that we probably don't know about. So if we do the run apt-get install y, in that case, ImageMagick, I'm going to come back to this package because this one is quite interesting. They might have some vulnerabilities that we're not aware of. So they could cover SSH or curl that could potentially be a point of attack for attackers. Also installing dependencies during runtime, which is something that you might reconsider. You don't want to install all dependencies on your container, so it's better to use the flag only production to avoid pulling dev dependencies and non-deterministic package install. Also, the runtime vulnerabilities. Actually, we're looking at the security releases because if we're picking a large image, it might have vulnerable libraries that we're not aware of. And I'm going to demonstrate this with the image magic. But here in this case, are we looking at the security releases from Node, for example, when we're actually fetching this image? So as I said, Snyk could give you that visibility and remediation for upgrading your base image. So it'll give you the current image that you're using, and you can compare it with alternatives, alternative upgrades. And yeah, you can go from there. And also, if you're not sure about the image that you want to use, you can actually use Snyk Advisor. So let's have a look here with Snyk Advisor. So in that case, I'm gonna click on the little drop down and select Docker, and I will have a look at Node image here. And this is giving you a few information on the number of stars, the number of downloads, but most importantly, the vulnerabilities that you can find on each version. So let's see if I select this one, for example, and if that's the version that you're using within your project, you can compare it with other versions. And if you want to upgrade to a safer version, you can go from there using Snyk Advisor. Cool. So let's have a look at the demo. So I was talking about Image Magic. So the team behind Image Magic actually created this dedicated website called Image Tragic, and where they explain there are multiple vulnerabilities in Image Magic. So Image Magic is a package that is used by web services to process images. So if you want to resize an image, you might be using this package. The bad news is one of the vulnerabilities can lead to remote code execution if you process user-submitted images. So I'm going to use this really fancy website, as you can see. Wow. They just to demonstrate how this RC is working. This is what I need for this proof of concept. But also, and this is a link that I haven't shared with you, Brian, let me just share it here. This is an interesting blog post that has been written by Liran on this exploit, actually, and he's going through in details of what is going on. So if you're interested in learning a bit more about what is going on behind the scene, this is a really interesting read that I would recommend. But basically, let's have a look at the Dockerfile. So this is the Dockerfile that we're going to use. And you might ask, Sonia, this is cool. I don't see the Image Magic package here. And you're right, because the Image Magic package is actually part of this Node image. So you wouldn't know, actually, if you're using that one. So this will be the two payloads that I'm going to use for this demo. The first one is, actually, I'm going to create just a file, a simple file called rc1. And I'm going to trick this application so the application will think that I will upload a JPEG, but actually behind the scene, I'll create a file. And before this, I've actually set up the scene to perform this RC. So let me just explain what is going on here. Cool. So as you can see, there's like 3 screens here. So first of all, this one is the first screen here on the left that is really squeezed, that we're not going to really use it, but this is just to spin up the local static server to serve the netcat package. The second one is the Docker image. So if I do who am I here, I'm unfortunately roots, but also this is to show that you don't see the RC1 file yet. So there's nothing here, and this is just the third. The first screen is actually the attacker screen to run netcats in listening modes and wait for incoming connection. This will be used for the other payloads. Well, we'll have the connection to this container. So let's go back to the application and let's upload the first payload. So just need to find it here. Cool. So this one is just going to create a file on the container. So I was expecting the image to be resized, but actually I have a broken image. So let's have a look at what do we have now on this container. Uh-oh, that's not great. We've actually managed to create a file on this container. Cool. So let's have a look at the other payload, which is actually the RC. So here we're still using the ImageMagick API, and we're actually going to trick the application by thinking that it's uploading an image, but actually we're going to upload the reverse shell. And in this case, you might think, because if we look at the first one, you could see the extension was JPEG. In this case, we'll be using a PHP reverse shell. But there's no, we can see there's no actually input validation here, because we would only expect images extension as we see. But yeah, apparently we can also upload PHP, which is not great. So let's have a look here. Let's go back to the home page, choose the file, upload the second one, and click on resize. So here we're not seeing the success screen. This is spinning, which is usually not a great news. So let's go back here and let's see what is going on. So I'm just going to put QMI here to make sure that it's coming back. I should see root. So this screen is the attacker screen, and I'm hoping to have the response from this little exploit. But let's have a look at what we have here. And you can see there's a lot of files that have been created, which is not a great sign. So what is going on here? We're going to have to wait about 20 seconds for the netcat utility to be downloaded. Here, from the first screen, the local static file server has to be compiled, executed to then create a reverse shell in the third screen, which is the attacker screen, just to create that connection with the Docker container, and then we can interact with it. So hopefully it will come back with root. And as I said, this is quite tricky because here we're using this specific node version, and if you don't do some sort of like due diligence to check what packages are included within this version, you wouldn't know that it's actually having this specific vulnerability. So let's go back here, and yay, I'm root. Cool. So yeah, this is quite scary. Let me just check which Python I have here. Okay, just going to change the shell just to have something a little bit more cleaner. PT1, spoon, better bin bash. Yeah, cool. So who am I? I'm root. Okay. And now what I can do is like anything as an attacker, because this is basically mirroring what I have on the containers. I'm just gonna minimize this one, and yeah, I can just like go crazy and just try to look for sensitive info, as you could imagine. So this is what I was on the third screen. This is exactly what you can find on the container that was showing. You can see the files that have been created. But yeah, as an attacker, what I'm interested in is sensitive info. Passwords can also exfiltrate data into our server. So yeah, this is basically I have access to everything now because I'm root also. So yeah, this is great. A bit scary, but in terms of mitigations, because you don't want this obviously to happen. So what I recommend in that sense is to change the version of the node version that you're using for the specific Dockerfile. Yeah, just to upgrade it to, I think it was the node version 8 that Liran recommended on his blog post. But yeah, cool. Also, we've produced a cheat sheet security best practices for Docker images, where we recommend to use minimal-based images, and also to use multi-stage builds for small secure images. So basically, when you're doing development, you could use larger images if you want to test experiments. But when you move to the production build, try to use smaller and clearer images. So what's the last layer? Because we've seen a few layers. So what's the last one? So we had the first layer, which is the application code, which is our proprietary code, then the open source code layer. Then we've been containerized in our applications with the containers layer. So what else? What else could we find? So the last layer is infrastructure as code. And this is an approach to manage data center, server, storage, and networking infrastructure. So it is meant to simplify large-scale configuration and management, because we're provisioning our resources through code instead of manual processes, just to make sure that our application is scalable and available. So you can make your code as your single source of truth, where you specify explicitly through code all the infrastructure specification in your config files. You can have version control on all of your config files. You can test and monitor your configuration. IAC is amazing, but also the most common vulnerability organization face is cloud misconfiguration. And this is referring to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. And you see a few examples here at the bottom of the slide. So PlayStation Network have 77 million accounts hacked. Uber had 57 million customer and driver info breach. So this happened because their repo switched from private to public, and usually hackers will spend some time on GitHub just to actually see if they can find credentials available publicly, and they could help them tamper with the application. So in that case, this is what happened. You also had for FedEx, the FedEx breach with 119,000 scanned docs. So let me demo the Snyk IAC. So here we have a Terraform file, which is, we might say is quite basic, just defining the provider. In that case, we're using AWS. And we're defining a few of our resources. Here we're defining a strict IAM account password policy. There's a few rules that has been commented out, so I can demo the Snyk IAC. But there's also a little bit of different modules around VPC, storage, CloudTrail, PKI, so different fragments that we're using for this Terraform. So let me just do the Snyk IAC test. And this is going to go through the Terraform, scan all the rules, and let you know how you can harden your infrastructure. So in our case, we're having no critical, 3 high, 9 medium, 7 low. Okay, let's have a look at what we have for the rules. So around S3 buckets, CloudTrail, credentials. What we're looking at here for this specific demo is around the password, the IAM password policy. So here we can see some recommendation. The IAM password should contain symbols, should contain lowercase, uppercase. Okay, so let's remove this. And we'll, whoop. Okay, and we run another Snyk IAC test and compare if we have better score. The number of issues should be lower on the medium side. Yeah, we did. So we did fix for medium here by enforcing our account password policy. Cool. If we're going back to the rules, you can see that you have on the CLI a little bit of info. You have also the rule link and a few other information. So what is it referring to? If you click on the link, you'll be redirected to this Snyk websites, where it will give you a little bit more info on the different rules. So in that case, we're trying to fix implement stricter IAM password policies. So this will give you a little bit more info around IAM password should contain uppercase, why, what's the issue, what's the impact, and how to resolve it. If you click on IAM, you'll have more rules around that. And obviously, it's not only about IAM. You have all the different services you could find for AWS. And also you can find it for Azure, GCP, and Kubernetes. So there's a few rules here that you can that could help you harden your infrastructure. And those rules are based against the CIS, which is for the Center for Internet Security. And these are guidelines that help you harden your different infrastructure. So this is where those rules are based against. Cool. So now I hope we have a better understanding of the modern application and the new risk profile that it brings. So at the top of the tip of the iceberg, you have the application code, which represent 10 to 20% of the code base. Then you have the open source libraries that we bring, and this could potentially bring also vulnerabilities, and this represents 80 to 90% of our code base. There's also the container layers when we actually containerize our applications, and obviously the infrastructure as code with misconfiguration that also brings that could bring vulnerabilities as well. So it is important to have those guardrails, security guardrails at each stages of your pipeline to spot vulnerabilities as your attack surface is getting bigger. So as I demonstrate today at the coding stage, you can test and fix through the CLI, through your IDE integration, and patches here to help you to fix those vulnerabilities. Also on the repo side, depending on the host that you're using on GitLab or GitHub, you can actually test, fix, and monitor on that side when you raise automated pull requests. Also on the CI/CD pipeline, this will depend on the workflow. If you're using Jenkins, Circle CI, Azure pipelines, or others, GitHub Actions, others, you can also implement guardrails at this stage, obviously on production and on the registry as well, to make sure that you're not fetching a malicious package or image. So it is important to have that DevSecOps feedback loop, because this is empowering developers to build applications securely within the entire development process. And also, we don't want to have silo team between security and engineers. So let's have a look at defense in depth with further practices and tech to consider. And let's start with the OSS level. So first of all, inventory your open source components. It's important to know what you have. Don't give hackers more tools to expand their exploits. Leverage security tools, just improve your OSS security posture in general. Embrace automation, because you don't want to have manual activities. Also include your open source software components in use within your security policies to have that visibility. And you can also produce SBOM, which is a software bill of materials, just to identify the packages that you have in all the licenses. You have that visibility. On the container level, don't run as root. You probably don't need it. Also, you probably don't need privileged containers. Drop capabilities when you can't. Just allow only what's needed. Don't add capabilities around SSH or curl. Probably don't need them on production. Read only file systems, and also deploy from known sources and pull from known registries only. And on the IAC level, make sure that your secrets are encrypted and you have role-based access control applied, that you have security context to make sure that you don't run as root. Also to have a zero trust network policy, and enforce and harden your infrastructure using different policies. So the open policy agent like Gatekeeper and the other tools that CNCF are providing, that could be good guidelines to harden and secure your infrastructure. So I'll finish with some of the top tips that I have. So the first one, adopt a DevSecOps approach. So this is the shift left approach, which aims to detect security issues from day one in order to prevent security vulnerabilities to begin with, and to resolve them as quickly as possible if they do indeed arise. To address open source vulnerabilities. While we here are all fans of the open source ecosystem, we know that because they offer a great number of benefits, including cost efficiency, they also expose us to significant vulnerabilities, and we've seen a few today. So when using OSS, it's important to have an ongoing monitoring for vulnerabilities, to have regular updates, and patch vulnerabilities as quickly as possible. 3, automate simple security tasks, because it's virtually impossible to mitigate the endless number of vulnerabilities that exist using a manual approach. So automation is critical, and all simple tasks should be automated in order to allow your teams to focus on more challenging tasks. 4, be aware of your own assets. So visibility is the first step towards gaining insights into your organization's security states, as you can secure what you haven't identified. So knowing precisely which assets make up your applications and software production infrastructure is key. And this goes back to the SBOM discussions. You have that visibility on the different components that you have within your project. And the last one, security training for developers. So developers are responsible for pushing code into production. So it's critical that they receive training from the security team. And obviously this training should be tailored to the specific developer's role and security needs, which is a nice segue to some useful resources that I want to share with you. So the first one is the Snyk Security Resources Corner, where we have a lot of really great cheat sheets on different topics. So because we're talking about JavaScript ecosystem, so I've linked with the NPM React best practices, but we also cover other ecosystem, PHP, Ruby, Go, and other, and you also have the Docker and Snyk log4shell remediation and best practices cheat sheets. Snyk Learn, great platform, really enjoying learning more about security vulnerabilities on this platform. And also it keeps progress. So if you want to start a lesson, then continue a bit later, you can do this. This is amazing. And there's also the launch of a new OWASP track. So if I go here, you can click on learning path, and there's the OWASP top 10 here. So yeah, you have, this is from the latest 2021 that I was referring to at the beginning of this session. This is the latest top 10 list, and there's a few labs around that if you want to learn more. So this is really cool. And the State of Open Source Security 2022. This is a joint effort, a report between the Linux Foundation Research and Snyk, just to give you more insights and info on the current state of open source software and how to improve your cybersecurity posture. And lastly, the State of Cloud Security Reports 2022. Also, this is a report to give you a better understanding of what is going on the cloud, what are cloud risks and security challenges that our organizations are facing in 2022. So, Sonia Moise, I'm a senior security advocate at Snyk. I'm passionate about DevSecOps, open source, and cloud security. I'm doing a few things outside of Snyk that I'm not going to bore you with today, but you can reach out if you have any questions or ping me at Sonia Moise on LinkedIn. And yeah, I just wanted to thank you for following and just attending this session with Pat and I. Hope that you learned a few things. And yeah, just to say that stay safe in your journey to cloud native application security. Thank you.
Nice. That was awesome, Sonia. And Patch.
Yay.
Well done. Well done. All right. I have one question for you, though. And hey, Nafron, thanks for being here. Well, one, shout out to everybody that's tuned in so far, that watched this and was here. We appreciate you. Thanks for being here. Hope you're doing well wherever you are in the world. Nafron, Robert Tables, Plain Text Nerds. I saw Amit over on YouTube. And I think I got everybody. Oh, Thunderblaze as well on Twitch. So thanks everybody for tuning in. It's awesome to see you here, and I'm sure you got a lot of value out of today's session. I have one question for you, Sonia.
Yeah.
It's a very critical question that's very on topic with today's session. Do you know what I'm going to ask you about?
No, I'm scared. What is it?
What is that amazing VS Code theme and like setup that you have? Can we please dive into that? I know we're at time, but I have to know. That looks sick compared to what you used to have, I think.
Oh yeah, I did a few I did a few tweaks
You have like
on this.
an animation in the background, like that
Yeah,
little
there's a little bit.
retro.
Yeah.
How is that
So,
possible? Are you using like a hacked version of VS Code?
so I did change a little bit the CSS on this. Yeah.
Oh no.
Yeah, there's a few changes, and I've also downloaded a specific font because you can see
Okay.
this is different. Yeah.
Yeah.
Because there's a bit of animated. There's a bit of zoom also on the
Yeah.
comments.
How is that? That's from CSS? Some type of styling that's going on?
Yeah. So this is from CSS, which I forget where. But yeah, this is from the settings, and this is I've seen it actually from a YouTuber.
Okay.
Completely forgot the
All right, no worries.
but yeah, this was from a YouTuber, and shout out to him because yeah, I've actually found it pretty dope. I wanted to implement
Yeah.
it. It actually looks really good.
I know it's very eye catchy. Like
Yeah.
sometimes it's hard for me to know where my cursor is at times and what line I'm on. And
Yeah.
like that's I really like that part of it too. So
Yeah. I mean, you can't miss this.
right. Yeah, there's no way.
Yeah. Yeah.
All right. Well, I'll find that out from you offline and then share with folks in the
Sure.
community.
Yeah, definitely. Yeah.
All right. Well, cool. Thanks so much, Sonia. Thanks again, everybody. If you're watching over on YouTube, be sure to like and subscribe to the channel. If you're on Twitch, be sure to follow so that way you don't miss any of the future live streams and content that we have on both these platforms. I think, and Sonia, you can keep me honest here, this may be our last live stream until the new year. Although I do see, and maybe you can confirm this, Micah is going to be doing a Java Stranger Danger
Yeah,
the 28th.
today was the last JavaScript session
Okay,
of the year.
so there
But
you.
there's another one, the Java. Next week or two? Yeah, there'll be another session
Yes,
for
that
Java. Yeah.
from what I can tell on the calendar, December 28th
Yeah.
at 11 a.m. Eastern time again. Um, Micah will be joining on this channel, wherever you're watching right now, where you can see basically a Java flavored presentation on what Sonia shared today. So if you're interested in that and seeing how it applies more specifically maybe to Java applications and what you should be thinking about and taking into consideration as a developer there, be sure to tune into that. If we don't see you though, have a good rest of your holidays and week and all that, and we'll see you in the new year. Thanks again for tuning in, and bye-bye now. See ya.
Bye.